Yes, I think so. I think we can start.
Yes.
Actually, I have a doctor's appointment. I have to see a doctor at 9 o'clock. So even if class doesn't finish, I'll go, but we can continue the class if it goes a little longer than that. Okay.
So good evening, everyone. I'll be discussing on corneal topography principles and interpretations today. So before going into the details, let's see how word topography is derived from. Topos means place and graphia is to write. This word is derived from actually from the study of surface shape and features of the earth, and this is taken to now to study used now to see the surface of the cornea. So as we know that there are two things available in the machines, topography and tomography. The difference between the two is in topography, we measure only the anterior surface of the cornea. And in tomography, we tend to see both anterior and posterior surfaces of the cornea. Topography is about only anterior corneal surface, whereas tomography scans both. Thus, pachymetry is not included in topography, whereas in tomography, pachymetry or thickness of the cornea is included. And in topography, it is not affected. It is affected by film and ocular surface diseases and ocular surface problems, whereas tomography is not affected by the tear film and ocular surface diseases. The advantage of topography is that topography is best in better when compared to tomography in the presence of corneal scars and haze, whereas tomography is less accurate in the presence of corneal scars and haze. So there are two techniques available while doing topography. One is the reflection based, that is Placido disc based technology, and elevation based technology, that is projection based technology.
What is an example of Achha, you're going to show?
So in Placido based technology, generally mites will be projected onto the cornea, and the reflections of the mites will be measured by the machine. The concentric rings of white and dark bands, and which are reflected from the cornea, is processed by the software in the machine, and it analyzes the distance between the rings, and it deduces the anterior surface of the cornea in terms of power. When the rings are too crowded and closer to each other, it indicates that the cornea is steep. When the rings are spaced away, far away from each other, it indicates that the cornea is flat. This is how the machine generates maps in Placido-based technique. So we have three types of machines which are based on Placido-based technique. That is keratometer, photokeratoscope, and video keratoscope. In keratometer, the scans are done only in 3 mm of the cornea. And in photokeratoscope, this machine includes even the paracentral area of the cornea, but it has a disadvantage that it leaves the center part of the cornea and the periphery of the cornea. The most advanced among the three is the video keratoscope, which covers almost 95% of the cornea. So these are in the order of the evaluation. So coming to projection-based or elevation-based corneal tomography, under this we have two types of technology: slit scanning technology and Scheimpflug imaging technology. Under slit scanning, we have Orbscan, and the advanced machines which are based on Scheimpflug technology or Pentacam series and Galilei. So under slit scanning technology, as I mentioned, that Orbscan is the machine which is based on this principle. It works on projection principle and measures the surface elevation by slit scanning triangulation technique, and also it uses Placido disc reflection technology too, along with the slit scanning technology. So in Orbscan, we have 40 scanning slits, two temporal, 20 temporal and 20 nasal to the right and the left. And a total of 240 data points per slit are used to scan the entire cornea from limbus to limbus. So when we multiply the 40 scanning slit beams with the 20 to 40 data points, a total of 9,600 data points of the entire cornea will be measured by Orbscan. Moving on to Pentacam, this machine is based on Scheimpflug Principle. So normally in conventional photography, all the planes, that is the object plane, lens plane, and image plane, are parallel to each other, and they are accurate while measuring planar surfaces in conventional photography. Whereas as a cornea is non-planar, so the object plane, lens plane, and the image plane, they should cut each other or intersect at one point to increase the depth of the focus. This is nothing but the Scheimpflug law. So Pentacam is based on this law, and this law is converted into Scheimpflug principle, where all the three planes intersect at one point and increase the depth of focus, and images the anterior corneal surface, posterior corneal surface, anterior lenticular, posterior lenticular surfaces, and also the iris plane. So in Pentacam machine, we have two cameras. One is static camera, which is present in the center of the machine, and it detects the pupil size and also maintains the fixation of the patient. And the other is a rotating camera, which is mounted on a rotating wheel to capture the cornea, and it captures the anterior segment and cornea from limbus to limbus and provides the 3D view of the cornea, anterior segment. And Pentacam has an advantage of capturing 138,000 true elevation points, unlike Orbscan, which scans lesser than this. And also, the other advantages of Pentacam is that it automatically corrects the small eye movements and also corrects the distortions caused by the camera optics, cornea, and the lens. So the other machines which are based on Scheimpflug principle are Galilei and Sirius. These two machines have common imaging technique based on Scheimpflug, and also includes Placido disc reflection technology. Difference between the two machines is that Galilei has dual rotating cameras, but Sirius, similar to Pentacam, it has single rotating camera. So now, while preparing the eye for Pentacam capture, make sure that the patient is seated comfortable, and patient should have a good eye exposure and avoid misalignment of the head. And make sure to ask the patient about the contact lens history and use. And if the patient has dry eye while examining under slit lamp, make sure that you're putting a lubricant eye drop before capturing the eye. So after the capture or test is done, we need to, while assessing the printout, we have to know that the colors which are present on the printout or the colors which indicate the corneal irregularities. And there is a scale for color coding. The cool colors, or the which are nothing but black and blue, they represent elevation points which are posterior to the reference surface, as shown here to the left, black and blue, and thicker surfaces in corneal thickness, which is present in the periphery here. And to the right, we can see that the flatter surface in the periphery shows the cool colors. And warm colors like orange and red, in elevation map, it indicates anterior to the reference surface. In thickness map, thinner surfaces are represented by warm colors, and in axial map, steeper surfaces are represented by warmer colors. So in the machine, we have color coding in terms of absolute scale and normalized scale. Absolute scale is used in commonly used maps in day-to-day basis, like 4 refractive map and 4 selectable map. And normalized scale is generally used in holiday maps and holiday EKR reports. And absolute scale range is between 9 to 101 diopters, and central area, that is between 35 to 50 diopters, it is divided into 11 graduations of 1.5 diopters interval. And beyond the 11 graduations, the interval is of 5 diopters. And this absolute scale, as I said, it is used for routine practices like 4-map refractive displays and for screening of the cornea. And in normalized scale, it is used for detailed examination. The scale ranges between 42.3 and 46.3. It is divided into 11 graduations and it has 0.4 diopters interval. And it displays the maximum minimum refractive power of the eye. So out of the 30 displays available in the Pentacam machine, these are the most commonly looked at or gazed at maps in OPD in day-to-day basis. And I'll be elaborating on quad refractive map and Dillon Ambrosio enhanced ectasia display today. So in quad map, we have to look at all these in detail, that is corneal parameters, anterior sagittal curvature map, pachymetry map, anterior elevation map, and posterior elevation map, which I'll be elaborating in the subsequent slides.
Dr.
So
Tulsi, what is the flattest and the steepest case that the Pentacam can capture as compared to the Orbscan or the topographer?
Actually, Pentacam can capture from 9 to 10 diopters.
Yeah, because I saw that you had mentioned from
Yes.
On the absolute scale that from 9 or 10 to 100, isn't it?
Yes. Yes.
So see, that makes it ideal for capturing our very flat corneas or very steep corneas like keratoconus, where it can go beyond 60 or 65 or 70 for the keratometry, and also for flat corneas like post-RK, where your K is maybe as low as 21 or 22, right? Which we don't get captures on optical biometers, and also on maybe even on topography, we are not getting. So would you know that Placido, what are the limits of the keratometries that a Placido map can capture?
Sir, it is around starting from 20, I remember. So I'm not sure, but it cannot capture very flat corneas.
So can you check on this tomorrow and tell us, standard topographers, for example, Atlas or Oculus, what is the range of keratometry that they can capture? Even in fact, if you can look up how much the Vario can capture, the topographer which we use in the LASIK center, and if you can update us on the doctors group tomorrow about the range of keratometry is possible with topographers and with this thing, and maybe even with Orbscan, what is the limit of the keratometries that can be captured? That will be useful to us to know like how to go about it. And one more thing, in your Pentacam map, in the initial slide which you showed, can you just go back 2 or 3 slides before this? Before this?
You want me to show the maps?
No. Go forward now. One more. One more. Yeah, another one. Yeah, so we'll stop here. No. Go back 1 slide and show me those 3. Yeah. Stop here. So on this, if you look at the extreme right, I don't know if you told that, maybe I missed it. In the extreme periphery, can you see those black dotted areas?
Yes, sir. Yes.
What does that signify?
That indicates there is inadequate exposure and we need to repeat the scan again.
No, not necessarily repeated, because these are extremely in the periphery. So you don't really need to repeat, because the information from there is basically the dotted area represents those areas where the machine could not capture. And so it is just extrapolating those areas and showing you a color coding. And you can select this to not be seen also. So if you, even on the topographer, so this is just like a machine is filling in those areas with a color which it thinks is, suitable for that area. But actually there is no data captured in those areas which are dotted with blue. So on the machine, actually there is a setting that you can go to the setup and ask it not to extrapolate data. So then it'll show all this area as white, right? So frankly, one must remember that if you're looking at these, if there are too many these dotted areas and coming more into the central area, then those maps are not of high quality. So one has to be careful when interpreting these maps. Huh? So let's go ahead where you were now.
So In corneal parameters, these are the parameters we have to gaze at while looking at the Pentacam map and going into the details of each individual parameters. And first and important thing, as Sir mentioned, that we have to look for presence of any black dots or whiteout areas, and also looking at quality QS. Quality specification is important before starting to look at other parameters, so that we can decide on repeating the Pentacam scans or not. The quality specification is not okay and the exposure is not good, it's always better to go back and repeat the scans. And moving on to anterior sagittal curvature map. Uh, so when you see a symmetric pattern, also called group A patterns, which are normal patterns, that is round, oval, and symmetric bow tie, it indicates that the patient has with the rule or against the rule or oblique astigmatism. These are normal symmetric patterns. And group C and group B patterns, asymmetric patterns and angular patterns, which are superior steepening, asymmetric bow tie, inferior steepening, and asymmetric bow tie with inferior steepening. These maps or suspect maps, and also along with that, if you see inferior superior difference of more than 1.5 in 3 mm zone in axial map, or superior inferior difference of more than 2.5 in 3 mm zone of axial map, it confirms the suspicious cornea. And in angular patterns, which have superior steep with the skewing of the radial axis and symmetric bow tie and asymmetric bow tie. The skewing is more than 21 degrees in 3 mm zone. It is suspect cornea, and astigmatism also should be greater than 1 Taptis. And when we see this special patterns like butterfly, crab claw, or vertical T or irregular clown pattern, definitely it is an abnormal cornea. So moving on to the tangential map. Tangential map, it is more sensitive to detect ectasia. So it evaluates the local radius at each measure point of data. Whereas the sagittal map, it doesn't localize the point, but it measures the points 90 degrees angle to its surface, reference to the midline as shown here. And sagittal map is or axial is the most commonly used map on day-to-day basis, and tangential map generally we use to detect ectasias and see the ectasias location of the cone in detail. The next parameter to look at is the K1 and K2, flat and steep case, located in the 3 mm and 5 mm zone. Generally, K2 is calculated from K1 by the machine. So when a machine calculates one value, it automatically calculates the other axis, which is located exactly opposite to the other K. The next parameter is K mean. It is a mean curvature power of the anterior surface of the cornea. It is also located in the 3 mm zone. And when the value is more than 48 diopters, then we should have a suspicion of keratoconus. Next thing to look at is the magnitude and axis of astigmatism, and also correlate the magnitude and axis of astigmatism with the manifest refraction. So astigmatism is nothing but the difference between K1 K2 on front and back surfaces of the cornea. And when we add the astigmatism in the front surface of the cornea and the back surface of the cornea, we get the algebraic sum of total. The sum of these two values gives us the total corneal astigmatism. Next thing is to look at the K max, which is maximum curvature power of the whole anterior surface of the cornea. It should be less than 49 diopters. And the difference, the general thing we tend to miss out in OPD is the difference of Kmax between the two eyes, which should be less than 2 diopters. And this also helps to monitor the progression in keratoconus. The other thing we can look for is the difference in the Kmax to K2 value. Difference in the Kmax to K2 value should also be less than it should be less than 1 diopters.
Also, Dr. Tulsi, if you just go back, there are a few other useful things there. There's a Q value which is there.
I thought I'll mention it later. Yes, sir.
Okay, so we can mention about that later. Also, since you spoke about the posterior cornea's, astigmatism and everything, what is the utility of the measuring the cornea's back surface? Like, where does it come useful, and where will you find that the astigmatism is up to what limit is it considered okay on the posterior cornea?
Posterior cornea, generally, this helps for us, especially in the toric IOL calculations, to know about the impact of the posterior corneal astigmatism on the total corneal astigmatism.
So, what to what limit is it acceptable, and what is the usual, posterior astigmatism compared to the anterior astigmatism? Like, for example, on the anterior cornea, if you have with the rule, what will you usually have on the posterior cornea? And to what limits is it considered normal, and where will we start thinking that we need to incorporate the posterior corneal astigmatism into our calculations for toric calculations?
0.2 to 0.3 posterior corneal astigmatism is the normal range, and generally posterior corneal astigmatism is against the rule astigmatism, as far as I remember. So.
I think you're right. And posterior corneal astigmatism. So one thing is application would be for, making toric calculations. It will tell you whether the toric calculations. You will need to consider the posterior corneal astigmatism. But what will happen to posterior corneal astigmatism in keratoconus?
Posterior corneal astigmatism will increase in keratoconus. I mean, the cornea will be ectatic, and it is more steep. Both the surfaces will be ectatic, so it steepens and the astigmatism increases. It adds up to the anterior corneal astigmatism.
Right. So we'll try to now look at, whenever we have cases of keratoconus, we'll try to see how the posterior corneal astigmatism behaves, right, in future. Because
Yes.
we don't normally pay attention to it, but maybe we can, right, to see if there's a pattern.
Yes.
Okay, especially in formicrustic keratoconus. For example, today we had that patient whose both eyes were showing, one had gone with high astigmatism,
yes,
and the other one had FFKC. We could look at that patient's posterior corneal astigmatism and see if it changes, right? So let's go ahead. Yeah.
Moving on to the pachymetry map, generally the machine displays the thickness map in two patterns. It can display in 5 values pattern, or it can show values all over the cornea distribution. The 5 values are nothing but the central value with the 4 values in the 5 mm circle. And the second pattern is, as we can see here, that the values are distributed all over the cornea. And the pachymetry map has 3 main landmarks. One is the corneal apex. The second is the thinnest location. The third thing to look at is the 2 opposing points in the superior and inferior meridian. So the normal difference between the superior and inferior point should be less than 30 microns. If it is more than 30 microns, it is a suspect cornea. Next thing we have to look at, and which is important to know about the alignment of the to determine the misalignment is nothing but the pupil center and the pachymetry vertex. So when we see that the pachymetry vertex is 0, it indicates that the alignment is good. And also pupil center should not be more than 0.05 in the x and x axis. So so here, as we can see, the pachymetry 474 value here is nothing but the corneal thickness, which is corresponding to the pupil center location and its coordinates. And pupil diameter is also important to look at, as the machine indicates here. And the next thing which should be seen is the angle kappa. So it becomes important if the pupil center is far away from the apex. And angle kappa, as we know, that it is the angle between the visual axis and the pupil center, and especially important in incorporating in refractive surgery evaluation. And normal value of the angle kappa should be less than 5 degrees or 20 microns. The other parameter which is very important is the thinness location. The thinness location, as such, the important thing to look at is the thinness location between the two eyes, the comparison between the two eyes. Thinness location, if it is less than 30 microns between the two eyes, it is normal. If the two eyes shows a difference of more than 30 microns, then it is a suspect, one of the parameter in the suspicious cornea. And the second thing which is important is the difference in the thickness between thinnest location, the pachymetry apex. This value should be less than 10 microns. If it is more than 10 microns, again, it is a suspicious cornea. And thinnest location, in thinnest location, among the X and Y coordinates, the important thing to see is the Y coordinate. The normal value should be less than 0.5 mm. If it is between 0.5 to 1 mm, it is a suspect cornea. If it is more than 1 mm, it is abnormal. Thinness location also helps to monitor the progression of the keratoconus. Moving on to the elevation maps. So the machine calculates the elevation maps in two modes. One is the float mode, as we can see here above, and below a picture represents the non-float mode. In float mode, reference surface is selected such that all the elevations and depressions are equal. In non-float mode, reference surface touches the apex of the cornea. So among these two modes, the best mode is the float mode, which highlights all the depressions and elevations of the cornea. And the reference surfaces which are used by the machine are best fit sphere and best fit toric ellipsoid. In BFS, it sees the shape of the cornea, but it doesn't detect the early keratoconus. But BFT, it detects early keratoconus. And BFS is especially used to locate the cone in keratoconus. Whereas BFT, it is helpful to evaluate the higher order aberrations. Am I audible?
Yes, very much.
Because I saw that Kamal has sent us the this. There is another Zoom link. Okay, which is at
That's
9.
probably because he thinks that the meeting might finish, so he must have sent it.
So in elevation maps, when we see the anterior float and the posterior float, we have to look for if the elevation points are more than 12 microns in front surface and more than 15 to 16 microns in the back surface. If it is more than that, it is suspicious cornea. And also we can assess the patterns in the elevation maps, which is not as important as looking for the numerical values in the elevation maps. The abnormal shapes are hourglass shape and central eye lines, and skewed hourglass and hourglass is a normal shape, skewed hourglass is a irregular abnormal shape, and irregular patterns are definitely suspicious of keratoconus. And moving on to the Q value, which indicates the asphericity of the anterior surface of the cornea in the central 6 cm zone. The normal value should be between -1 to 0, and average of around minus 0.27. If the value is around 0, it indicates the cornea is spherical, and especially in myopic refractive surgery, the value will be altered. It will be a positive value, more than 0, and if it is in negative value, then it indicates that it can be keratoconus or it is operated for hyperopic refractive surgery. So the next thing, a parameter to look at is the anterior chamber depth. We have to look for both external and internal. Especially internal is very important for phakic IOLs. If the internal ACD is more than 2.8 to 2.9, then it is favorable for phakic IOL implantation. And also we can look for AC angle here. If the angle is more than 30 degrees, then it is favorable for phakic IOL implantation. And also we can assess suspicious angle closure glaucoma. If the anterior chamber ACD is less than 2.1 mm, or the anterior chamber angle is less than 24 degrees, or the other parameter can be which can be seen as the anterior chamber volume, which is less than 100 millimeter cube. All these three values indicate that the patient has suspicion for angle closure glaucoma. The other parameters we have to look for or the IOP and white to white diameter, and also we can assess lens thickness and densitometry, and also aberrations of the cornea. So the next display I'll be elaborating on is the Bellin-Ambrosio enhanced ectasia display. So this displays it accentuates the ectatic or conical regions of the cornea. So this map is calculated by determining the best fit sphere from central 8 mm zone after excluding all the data from 3 to 4 mm optical zone centered on the thinnest part of the cornea. This is how the map looks like, and this helps us to rule out the suspicion for keratoconus or presence of keratoconus. And the other important thickness profiles we have to look at in near the bad map is CTSP and PTI. Corneal thickness spatial profile, it describes the average progression of the thickness starting from the thinnest location to the corneal periphery in relation to the concentric zones along the thinnest location. And percentage thickness increase, it describes the percentage of progression of the same uh, thickness. And normal profile, it generally it is a curved line plotted in red dots and following the course of the normative black dotted curves. And these are the various slopes that we can see. If it is a quick slope, then we can see a value of more than 1.1. And H shape, flat shape, and inverted shapes can also be seen. A flat shape, it indicates that the cornea thickness is uniform from center to periphery, which generally happens in Fuchs dystrophy. And inverted shape is generally seen in pellucid marginal degeneration, and S shape is generally seen in keratoconus. And the other values which are important are the D values. So the various D values which are displayed in the at the bottom of the bad map. DF is nothing but the front surface. P represents back surface, and P represents pachymetric values. T represents the thinnest point of the cornea, and I'm not sure about the A, sir, but D which is present at the last is the overall final of the all D values.
Thanks. So, okay, so we can go on.
The 4 indices for screening keratoconus was the central corneal power, if it is greater than 47.2, or inferior superior asymmetry of more than 0.4 diopters, and astigmatism of more than 1.5 diopters, and skewing of the radial axis more than 21 degrees indicates suspicious keratoconus. And KISA index, if it is less than 60, it is considered a normal cornea. And between 60 to 100, a keratoconus suspect, and more than 100, a keratoconus cornea. So overall, when we look at a Pentacam map, these are all the red flag signs we have to remember to rule out keratoconus. Kmax should be more than 48.7, and Kmax difference between the eyes should be more than 2 diopters. Kmax to K2 difference should be more than, and skewing of the radial axis of more than 22 degrees, and inferior superior asymmetry of more than 1.5, and superior inferior asymmetry of 2.5. And this is an axial map. And in the pachymetry map, sagittal map, or in the pachymetry map, central corneal thickness of less than 470 with a normal topography, and or less than 500 microns with abnormal topography. And pachymetry apex to thinnest location should be more than 10 microns, and thinnest location y coordinate should be more than 500 microns. And as I said, the difference between the thinnest location between the two cornea should be more than 30 microns. And inferior superior asymmetry in the pachymetry map should be more than 30 microns. And when we look at the elevation maps, if it is a best fit toric ellipsoid, then elevation point should be more than 12 microns in the front surface, and more than 16 to 17 microns in the back surface. When we are selecting best fit sphere, in myopia, it should be more than 8 microns in the front surface, and 18 microns in the back surface. In hyperopia, it should be more than 7 microns in the front surface, and 28 microns in the back surface.
So, what is the usual difference in the superior and inferior cornea as far as the pachymetry goes? So, if we took symmetric points between, for example, at the edge of the pupil or something, would it be thicker superiorly or inferiorly?
Corneal thickness is generally more in the inferior region when compared to superior region.
So, what is the usual, like normal? You said it's more than 30. If it is, then it's significant, right?
Yes.
If you're looking at inferior superior.
Yes.
Right. So, okay. So let's go ahead. I'll have to leave in maybe 5 minutes, and then Dr. Ruchika
Yes.
will take over. Huh?
So, to say that the keratoconus is progressing, the Kmax should be more than 1 diopters, and pachymetry, there should be 2% decrease in the pachymetry between the two visits, and manifest cylinder should be more than 1 diopters between the two visits within a span of 1 year, and 2 years. And change in the manifest spherical equivalent should be more than 0.5 diopters, and K mean should be more than 0.75. And these are the important things we have to look at to say that the keratoconus is progressing. So, the uses of Pentacam or tomography as such is for planning for the refractive pre-op and post-op assessment of refractive surgery patients, and to diagnose ectasias, and also cataract surgery.
Can we continue with uses of tomography in the next class? Maybe, I don't know. It's because
This is
if
the
we are
last.
switching, okay.
And for glaucoma evaluation and contact lens fitting, and astigmatism correction after corneal transplantation.
Can we go into more detail of the Bellin-Ambrosio maps and how to interpret them in the next class? Like, like the how to use the, for example, the thinnest pachy like you showed. So on that map, for example, rather than use the on the apex, we were talking about that and how to go about like each parameter. Can you show me the Bellin-Ambrosio map on your?
Well, okay.
Yeah, stop there. So, for example, if we can go stepwise on each of the, the indices which are shown on the upper screen, part of the screen, and then also can we talk a little more about how to interpret from the, various D things at the bottom? That will help us probably understand it even better because, we tend to use this every day. And maybe you can take help from Dr. Ruchika on this, that how to, kind of use the bad maps better. And that way we can. So next class, we can start with that and then go to the other indications and everything in more details.
Yes.
Okay. So, any other comments, Dr. Amrita, Dr. Vichika, anything?
Yes, I think this part is very important actually. There are a lot of indices that we need to look at in the bad maps. So I think it will be useful to discuss this a little more in detail.
Right. And also about the, see at the bottom, if you look at the reference database between myopic normal and the hyperopic mixed cylinder. So I think all these small little things and how to even look at the corneal pachymetry maps and then the colored maps on the left, the elevation maps, all these things, how to use them. So I think we need to probably go into more detail on this, how to use this. So I think we should start our next class with this and then go on to the other stuff.
Yes, sir.
Yeah. Yeah. So I think I'll have to leave. Thank you so much for a very nice class, Dr. Tulsi. And you guys can continue with the discussion if you have any. I'll have to go because I have an appointment. So if you'll
Okay.
excuse me. Huh? Thanks. Thanks.
Ma'am, do you want to add anything to the today's presentation or from your side?
No, whatever you covered is good, but yeah, all this and then the ABCD progression and then details about where sometimes there are a lot of we get what do you say fallacious red flags on the bad maps. So what all are the reasons why we get that and how we can correct that? Then also a little more in detail about the PTI and all the indices that are given below the PTI
Sure.
and the ABCD progression, although I don't
And
know
also
practically.
aberrometry, because of time shortage, I couldn't cover. I was supposed to cover aberrometry, Scheimpflug display, and as you mentioned, ABCD progression display.
Yeah, and maybe you can even talk about the EKR maps.
Holiday.
I mean, basically what we use on a day-to-day basis, whatever is important. And also,
Okay.
I'm not sure if I missed it, the different kinds of reference surfaces and also how you can change. You can talk a little about the settings also, like how you can change the reference surface or how you can change the scale or how you can, all those things also. Maybe with the help of like the drop down box where all you can go and select what.
Yes, ma'am, sure.
You can do that. That can be a bit superficial. It's not that important, but
actually, there are 30 displays which were available. So I wanted to speak at least one line about each display. But in the next class, I'll try to include all those displays and, as you mentioned, the settings about settings and this bad map in detail.
no need to talk. No need to talk about all 30 displays. Even if you tell about one, we'll know like basically how to go about changing the settings and the different displays. You can just take one as an example. You need to show all of them.
Okay, sure.
Because all 30 are not relevant also.
Yes, yes.
Okay. Yeah.
Amrita, do you want to?
I just wanted to ask that bottom right thing, the reference database, this will cover in the next class now because I couldn't understand this too much when you explained right
Yeah,
now.
actually, I didn't elaborate about it because I also couldn't find time to do in detail. Next
So I
class.
think we are going to anyway discuss about the bad maps in the next class. Yeah, so I think we all can read about that and discuss that in a little more detail to know about it.
Chalo, then I think we can.
Oh, okay, ma'am.
Yeah.
Thank
Okay,
you.
ma'am. Thank you.
Yeah. Good night. Yeah.